For the first question, we asked that figure 1 is an illustration of two methods of vegetative propagation in flowering plants labeled A and B. So from stage A1 through to B2, and study the figure carefully and answer the questions. Start with A. The A says name each of the methods of propagation A and B. So the A, which is this one, is budding. budding. So budding. Then the B is grafting. So this budding, this grafting. Alright. So the next one, we are asked to label the parts I to V. So I, which is this, is the bud. Then I is the remains of the bark. They cut the bud, which is what I'm pointing here. They cut the bud from a tree. So what you have here, what I'm cutting out, actually remains of the bark. Then I is the stalk on the tree from which the bud was cut from. Then ivy is the scion. That's what is being attached to the plant. It was cut from somewhere. So the ivy was cut from one tree. Then the vein. The vein is also called the stalk, the root stalk. We move on to C. Now we are asked to state one observable feature right from A1 through to A2, A3, B1, B2. The observable feature for A1. Now let's observe and look at it very well. A1 is the bud. Now the bud is small and also it has an oval shape. Yes, it's a bud and it's small, it has an oval shape. Then the A2, the observable feature is that the T-shaped incision has been made on the stalk. Then the A3, the bud has been inserted into the T-shaped incision. Yes, the incision on the stalk. Then the A3, the bud has been inserted into the T-shaped incision made on the stalk, and then it has been tied. It has been tied firmly. Then for the B1, the scion and the stalk are present, but they aren't attached. Yes. But for the B2, the stalk and scion are present, and then they have been joined together or tied together firmly. And we observe that their diameters are also similar or the same. Then the D, we have been asked to state two precautions in the method labeled A, which is the budding. When cutting the bud, make sure you use a sharp cutting tool so that you don't get a rough, bud, which wouldn't be compatible for the vegetative propagation. And also the budding operation should be performed early in the morning or in the evening. Then the next question says, give one local example of each of the plants which could be propagated by the method illustrated in A. So which plants could be propagated using budding? So we can have citrus like orange and then lemon as well. Then for the B, orange and then guava.
So the link you are seeing on the screen is my official Telegram channel. Kindly check the video description and then tap on it to join to get more information about study tips, listen to my free podcast, and then other courses I have designed to help students to learn how to study.
Figure 2 is an illustration of a field crop labeled C and a crop pest labeled D. Study the figure carefully and answer the questions that follow. So C here is a stem tuber. B says name one characteristic feature of the crop labeled C. They have a rough scaly skin. They are not very bright in color. Then C says describe briefly how crop C could be propagated. Could be propagated using the right word is set. They are buried in mounds and mulched to withstand um, long periods of drought. So what's a mound? So by earthing up, by raising the level of the soil. Then the next question is state three cultural practices that could promote healthy growth of the crop. So weed control, staking, yes, mulching, then pest control. Alright. Then E says state one kind of damage caused by D to C. So one damage is crop spoilage or crop damage. Then II says name the group of pests to which D belongs. D belongs to rodents. Then name two other organisms that belong to the same group. Two other organisms are mouse as well as grass cutter. They are all rodents. Then state two ways in which pest D can be controlled on a farm of crop C. So by setting traps and also using rodenticides. So question 3. The figure 3 is an illustration of a setup to produce a gas in a laboratory. So you are supposed to study the figure and then answer the questions. So this is the whole figure. So the first one, we are asked to name the part labeled I to vein. So I is a flat bottom flask. Then the II is a cork, C-O-R-K. III, thistle funnel. Then IV is a delivery tube. So vein is a gas jar. We're just asked to name from I to vein. So we stop there. Then the B says state the function each of the parts labeled IV. So the function of IV. It is used in delivering the gas into the conical flask. The function of the concentrated sulfuric acid is to act as a drying agent so as to dry the gas. Yes. So C says state two suitable acids that could be used in the experiment. Suitable acids that could be used in the experiment includes nitric acid and then phosphoric acid. Name the gas produced from the experiment. Okay. The gas produced from the experiment is CO2, carbon dioxide. It's called carbon dioxide or carbon dioxide. That's the IUPAC name. And next one says state one physical property of the gas. The gas is odorless. Yes. And then state the mode of collection of the gas. The gas is collected by downward delivery. Give one reason for the mode of collection stated. Okay. It's collected through or by downward delivery because it is heavier than air. Describe briefly the test for the gas produced. Okay, so a simple test could be to get lime water in a test tube and then get a straw and then blow air into the lime water. Because there's carbon dioxide in the air that is blown into the lime water, it will turn milky. The milky color indicates the presence of carbon dioxide. Then the next question, question 4, it says figure 4 is an illustration of an experiment to investigate the relationship between power of an electrical appliance and current. Figure 4 is an illustration of an experiment to investigate the relationship between power P of an electrical appliance M and the current flowing through the appliance. So this is the figure. This is the electrical appliance. And I want to know the current that is flowing through it. Now when it comes to science practical, always expect a graph. Always expect graph work. you should know how to do your graph very well and your gradient. So the next thing we have here says that M represents the electrical appliance and W represents watt meter. Now, if you know what power is, definitely you know that it has to do with watt. Now, and also always expect electrical energy in the practicals, in the theory, in objectives as well. So you should master electrical energy. Is a topic you should know it so well. If nothing at all, you know electrical energy because you know it will always drop. The current through the appliance was varied 5 times, and each time the power was measured. Figure 4. So this is figure 4. Now we are supposed to find the readings and the readings for the current and then for the power as well. Now with the current, I can help you out, but with the power, since it's on my screen, I can zoom in, I can zoom out, so I might not get the right dimension for you. So you would have to get questions and so on back. I can go through with you, especially with the Watomi. I'm just going to do something very basic for you to understand, because this doesn't look like a reading that is very easy to get, because when you try 0 0.1, 0.2, 0.3, you didn't get it to the 5, and you can try 0 0.2, 0 0.4, 0 0.6, you wouldn't also get it. But there's something I always love to do when I'm studying, which is to use something that is very basic to relate to something that looks difficult. What do I mean? Now when you pick your rule, should I even use a rule? No. Let me just draw something here. So you have 0 here, you have 5 here. Now, how would you know the smaller dimensions? 0, 1, 2, 3, 4, 5. Great. But mathematically, how can it be calculated for? Now, this is how you go about it. You always pick consecutive readings that are indicated on whatever instrument you have. Now, this is the instrument I'm using to explain. I'm trying to use this instrument to explain how to do the reading. So this is a formula that you wouldn't find in any book. So let's go. So I said pick consecutive readings. So this diagram I've drawn here can continue till you have 10 here. So as you can see, so we have 5 here, we have 10 here, we have 10 here, we have 15 here. So you can just pick 5 and 10 or 10 and 15. But don't pick 5 and 15 because they are not, it doesn't follow. 5 follows 10, 10 follows 15. So with what I have here, I'm going to pick 0 and 5. And then what you do is subtract the smallest from the biggest. So after you've picked the two consecutive readings, so 5 minus 0 over, now count the spaces in between. 1, 2, 3, 4, 5. So 5. So 5 minus 5 is what? 5 over 5. 5 here 1, 5 here 1. So the smallest dimension or the smallest reading on this instrument that I have here is 1. That's why I can move 0, 1, 2, 3, 4, 5. So we are going to use the same understanding. So we are going to look at, already we know the smallest and the biggest unit, the smallest and the biggest dimension. So we know the consecutive dimension. So we are going to count the smaller spaces between. So just move with me. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we want a reading that is uniform. We got 14 from 0 to 5. Now let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This question looks very unique. Realize that the readings in between them are not even uniform. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got 15 over here. So let's go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would want us to work with the 15. I want us to work with the 15, even though we got 14 here. Because, any proper instrument should have regular dimensions. I don't know why. That's how the question is. And sometimes, they make the question this way too. Sometimes they just shake you, but if you're experienced, you know what you do. So, by getting that, I know that so using the formula or the strategy I used, so you are going to pick, you can pick any of them. You can just pick 10 and 15, 5 and 0. So that's the biggest one, 5 minus 0 over 15. 5 over 15. When you do your division, we are going to get 0.333. The smallest dimension is 0.3. So let's see. So 1, for this, you are going to use the lines instead of the spaces in between. 1, 2, 3, 4, 5, 6, 7, 8. 0.3 plus 0.3 8 times. And since we are mathematicians, we know that we can just multiply 0.3 times 8. And 0.3 times 8, we are going to get what? 0.24. So for the first one, 0.24. Good. So we are here as well. So we know this will be 5.3, 5.6, 5.9, 6.2, and so on. But I wouldn't want to do it that way. Let's still use the 0.3. So 1, 2, 3, 4, 5, 6, 7 is on the 7th. Since it's on the 7th, 0.3 times 7 will give you 2.1. Now, your answer is not 2.1. 2.1 plus 5 is 7.1. Alright, so we go again. 1, 1, 2, 1, 2, 3, 4, 5, 6. So 0.3 times 6. So 0.3 times 6 is 1.8. Yes, 1.8. So 1.8 plus 10. I hope you know I'm adding to the 10. I'm adding to the 10 because it's 10. When we started from 0, it was just 0. So 0.24 plus 0 is still 0.24. So 10 plus 1.8 is 11.8. 11.8. Then for the last one, 1, 2, 3, 4, 5. 0.3 times 5 is 1.5. 1.5 plus 15 is 16.5. So this is our reading. Unfortunately, we can't do the graph here, but I'll show you a diagram of the graph. Then you get a bigger picture of what's actually happening. Okay. So with this one, all you have to do is use your rule to measure. So you put in your values for the current. For the current, you just write what we did. It's in ampere, so all you do is just use those figures we got. But looking at this one, for the raw values of power in centimeters. Now, power is not in centimeters actually. So over here, what you write is your ruler readings, the reading you got from your rule. But here is the actual power. Now there was a scale that was given. Every 1 centimeter equals 100 watts. So whatever dimension you want, multiply by 100 and then write at the actual value side. So you plot your graph and determine the slope.